Hi, my name is Neal Damani, and this is my Lab 1 over charged tapes. The purpose of this lab is to observe the interactions between two pieces of charged tape with each other and other objects to determine if they gained or lost electrons. The results showed that the charged pieces repelled each other and had a charge of 1.12 times 10 to the negative 8th coulombs, and the tape was deficient of 7 times 10 to the 10th electrons. Some of the principles utilized in this lab were Newton's law, which states that force equals mass times acceleration, and was used to determine that the net force of the tape is zero. We also used Coulomb's law to determine the electric force and charge on the tape. Gravitational force was set equal to the electric force to solve for the charge. Some assumptions necessary for this lab were to assume that air resistance is negligible, the tape acts as a point charge, and the U tape had an evenly distributed charge. For our experimental setup, the system is tape A and tape B, and the surroundings are everything else. For our initial conditions, there were two neutral pieces of tape that were equal in length and a third piece of neutral tape that was stuck to a desk. I began by sticking tape B to the base tape and ripping it off to create a charge. Then I placed tape B near objects of different charges to determine its overall charge. Tape A was then charged in the same way as tape B, and then tape B was placed near tape A until it began to float. Then the distance between the two was measured. For our experimental values, for my setup, the length of the tape was 0.2 meters, the mass of the tape was 2 times 10 to the negative fourth kilograms, the distance between the two pieces of tape was 0.024 meters, and the magnitude of the gravitational force was 1.96 times 10 to the negative fifth newtons. The magnitude of the electric force is equal to the magnitude of the gravitational force since it was floating in place. Finally, the electric charge is equal to 1.12 times 10 to the negative eighth coulombs. I expected the two pieces of tape to repel each other, and that's exactly what happened. The U tape was attracted to my hand, a neutral book, and a negatively charged pen were repelled from another piece of U tape, proving the U tape to be positive. Because the momentum of tape B is not changing, we can conclude that the net Y component is zero. The tape exerts an upward force on tape B, and the Earth exerts a downward force, which is shown in the free body diagram below, next to number 3. Finally, mass needs to be measured to determine the gravitational force on tape B. The number of atoms on the sticky surface of the tape is calculated by dividing the area of the tape, which is 1 times 10 to the negative 20th meters squared, by the area of an atom, which is 0.004 meters squared, and this gives a value of 4 times 10 to the 17th atoms. The ratio of number of electrons to the number of atoms is the number of electrons lost, which was calculated to be 7 times 10 to the 10th electrons divided by the number of atoms, giving us 1.75 times 10 to the negative 7th electrons per atom. For our code, this initial part shows some of the variables such as the tape surface area, tape length, tape mass, the distance that the two pieces of tape were apart, and the areas. Apart from that is the calculations for gravitational force, electric force, charge, deficient electrons, the number of atoms, and the ratio of deficient electrons to atoms. On this coding part 2 slide is the actual output of the visual along with all the numerical information, and the code shows where I created the visuals such as the U-tape being the spheres and the forces being the arrows. For my closing questions, what if the electrons had a positive charge and protons had negative charge? What would change about the observations you made? It wouldn't really change anything given that opposites would still attract and the same charges would still repel. And then for why is it important to handle the charged shapes as little as possible? What happens when the charged shapes come into contact with your hands or other objects? It's important to handle the charged shapes as little as possible to ensure that I'm not removing any protons or electrons through touch. If charged shapes came into contact with my hands or other objects, the charge would change and it would either amplify or lessen the effects of attraction or repulsion. For my conclusion, it verified it's true that the concept that same charges are going to repel and opposite charges will attract. Some sources of error that the charge shape interaction with other elements in our environment could have changed some of the charges, and then the charges on the tape are not necessarily equal. There's a potential that they weren't. And then for my conclusion, the tapes became positively charged once ripped off from the table. Tapes repelled each other and attracted to neutral or negatively charged objects. It shows that linked charges attract and opposite charges repel, and objects can easily become slightly charged through touch. Thank you.